So today we are going to add the relation of identity to predicate logic. We're going to augment the language by adding a particular relation that does some very useful work for us and expands the expressive power of the language. So in English, the word is has at least two different meanings. And in predicate logic, we want to be able to distinguish these. So you can easily understand this by thinking about these two sentences. Tony Stark is awesome. Tony Stark is Iron Man. Now, the first use is the one we're used to, and we call this the is of predication. So it simply predicates the property of awesomeness to a person named Tony Stark, and we write it the way we are used to writing that, big A, little t. But Tony Stark is Iron Man sounds rather different. If you weren't thinking too hard about it, you might say, well, okay, Tony Stark, little t, is Iron Man, big I. But then if you think a little more, you'll say, well, is Iron Man a property? Is there such a thing as Iron Man-ness? No, that's not what's being said. These are two different names for the same guy. So that just is not right. So what is right? Well, we are going to invent a way of doing it right by adding the equal sign, the identity sign. So the way we will legitimately say Tony Stark is Iron Man is by adding the identity sign to the language. And so now we can just write Tony Stark is Iron Man as T is equal to I. Right? So Tony Stark and Iron Man are both names. We're going to set them equal to each other. And this is telling us that these two names refer to the same individual. So if you're thinking about this, you might actually ask why we even need to do this, right? Why don't we just define a predicate, say E to mean equals, so that we could just say, for example, equals A, B, like that. And the answer to that is, well, actually we could do that. But later on, we're going to be developing the predicate calculus, which is the proof procedures for the predicate logic. And it turns out that we have specific proof procedures for the identity relation. So we actually do need a dedicated symbol in order to do that. So the important thing to understand about the identity relation, though, is that it really is just a regular two-place predicate. So it holds between names and variables, but not between predicates or propositions or entire sentences. So this is right. It's like A is identical to B, or there exists an X such that for all Y, X is identical to Y, but this is wrong. P equals Q, whether P and Q are understood as symbols in propositional logic or as predicates in predicate logic, that's wrong. And we don't have, the identity relation is not defined on propositions. So we don't talk about one proposition being identical to the other in predicate logic. Now you might also wonder actually why it is that we write it like this. Why is it we write it like this with the identity relation in the middle? After all, of course you're used to that, so it doesn't strike you as odd. But you might say it's kind of inconsistent because after all, this is the way that we've learned to write relations with the relation on the front. The answer is just really it's too weird looking, and people are used to using the identity symbol by putting it in the middle. So that's just the way the system draws it up. Okay, so what can we do with the identity relation? Well, the answer is we can do a lot. We can say all sorts of things that we really couldn't say before. So think about statement like God exists. Believe it or not, we actually could not say that properly without the identity relation. Now, you might have tried. You might have said, well, why not? Why not just say big E, little g, exists God? The problem with that is that existence is not a predicate. It's not a property in predicate logic. Existence is, as you know, it's a quantifier. I'm just going to say that it is a quantifier. This actually masks a lot of debate, a lot of historical debate about the nature of existence. Is existing a property of an object? Was a really long philosophical debate. And some of the heavy hitters like Kant and Hume talked quite a bit about it, but the sort of the answer is that it's been sort of generally appreciated that it isn't, although there are some philosophers who would argue that it is. So anyway, in predicate logic, it's not, for sure, it's not a property. So the way we would say that God exists in predicate logic is this. We'd say there exists something, there exists an X, such that X is identical to God, right? So God exists, there is something, and that something is identical to God. Notice, by the way, there's no parentheses here, right? We don't put parentheses. We don't write it like this. There exists an X such that X equals God. Right? Just like we don't write this. There exists an X such that R X G with parentheses, right? Neither of those are right. That's wrong. That's wrong. We don't write like that. The formation rules don't permit introducing parentheses in that way. So resist that if you feel like it needs it. It doesn't. Now we can also say things like this. There is only one God. Now you might pause and see if you can figure out how this would be said. There is only one God. And notice here that the word God is functioning not as a name, as a predicate. So we can talk about God. God exists. In that case, we're using God as a name. Here we're talking about godness, right? To be a God. So there's only one God. It's a different kind of statement. It's a property that we're predicating of things, but we still need identity to do it. So what does this say? This says that there exists an X such that X is a God. Okay, so there is a God. There's only one God tells us there is a God. So there is a God. And for all Y, if Y is a God, then Y is identical to X. You get that? So there exists an X such that X is a God. There's definitely a God. And then for all Y, if Y is a God, then Y is identical to X. Put differently, if there's a name, right, if there were a different name introduced for God, then that would be just a different name for that very same thing, like Tony Stark and Iron Man, right? So there is a God, and for all Y, if it's known by another name, then it's really a name for the same God. This also is an interesting sort of philosophical topic, right? I mean, philosophers of religion like to wonder whether all these different religions that exist in the world and have existed in the world are all referring to different gods, or really they, unbeknownst to the followers of the religion, they're really worshiping exactly the same God, and they just have many different names for the same being. So there exists an X such that X is a God, and for all Y, if Y is a God, Y is identical to X. Now, these quantitative statements involving larger numbers get more complicated. In fact, I'll never ask you to think about more than 2 or 3 because they just get kind of Byzantine. But it's important to see that we have the tools for representing quantitative statements like this if we need to. So there are at least 2 apples. Now, you should go ahead and pause and see if you can figure this out. But basically, just notice that when we say there's at least two apples, we're saying there are two distinct apples at least, but there might be more, right? So there might be 3, 4, 5, but there are at least two. So how would we say that? Well, essentially what we want to say is that there exists an X and there exists a Y such that X is an apple and Y is an apple. And they're not the same, right? They're not identical. So there exists an X and there exists a Y such that X is an apple and Y is an apple. And it's not the case that X equals Y. Now that leaves open the possibility that there's millions of apples, but there are at least two. All right? So now think about a statement like there are at most two apples. What do we mean by that? We know what we mean when we say there are at least two apples. I mean, you know what these mean in English, but when you start thinking about them, it's easy to get confused, right? So there are at least two apples means that there could be a lot more, but there are at least two distinct apples that aren't the same. There are at most two apples tells us that there are no more than two apples. Now this, interestingly, is consistent with there being 0 apples, right? There could be 0 apples, and if there's 0 apples, it's still true that there are at most 2 apples. That's an important thing to understand. So there are at most 2 apples tells us that there are no more than 2. So the way you could think about this is you could say, look, suppose somebody said, you know what? A is an apple and B is an apple. And you know what else? C is an apple. Now, is there any way that this statement is consistent with this statement, right? Because this says there are most 2 apples, and this appears to say that there's 3 apples. But in fact, this does not really say that there are 3 apples, right? Because one could be Tony Stark and one could be Iron Man. In other words, they could be names for the same thing. So what you want to say is, look, there are at most 2 apples. So if you're going to say A is an apple and B is an apple and C is an apple, well, what I'm going to tell you is this. Either A is identical to B or B is identical to C, or what? A is identical to C. Now, when I say either, I don't mean the strong sense of either or. It could be they're all identical, right? Because there could just be 1 apple. There could be 0 apples. So if you understand that, then you'll understand this. A little bit long, but not particularly difficult to understand. So for all X, for all Y, and for all Z, if X is an apple and Y is an apple and Z is an apple, then guess what? One of them are the same. Either X equals Y, or Y equals Z, or X equals Z. So the important thing to understand is that this does not really tell us, if you were to read this, it doesn't say if there are 3 apples, right? Basically it says if there are 3 names for apples, then 2 of these names are referring to the same apple. Got it? Now we can also say things like this. Tony is the only one who isn't freaking. How would you say this? Try it. Tony is the only one who isn't freaking. Now what this tells us is that Tony isn't freaking, right? We know that Tony is not freaking. But we also know that if anyone else isn't freaking, then that person is Tony, right? So this sentence doesn't just say that Tony isn't freaking. It says that Tony isn't freaking and nobody else isn't freaking. So we can say it's not the case that Tony is freaking, and for all x, if it's not the case that x is freaking, then x is identical to Tony, right? So Tony isn't freaking, and for all x, if x isn't freaking, x is Tony. So imagine somebody saying, but wait, Iron Man isn't freaking either. Well, that's right, because Tony is identical to Iron Man. I think this one you can probably do on your own. Think about a statement like, Tony is the dude who saved Bunny. Go ahead and pause this and give this a try. So Tony is the dude who saved Bunny. Tells us that, well, first it tells us that Tony saved Bunny, right? But when we say Tony is the dude who saved Bunny, we mean there's one guy who saved Bunny, and that's Tony. So Tony is the dude who saved Bunny and nobody else saved Bunny. Now the way we say nobody else saved Bunny is for all x, if x saved Bunny, you got it, x is Tony, right? So Tony saved Bunny, and for all x, if x saved Bunny, then x is equal to Tony. Now, if you had written this as you could put the quantifier totally on the outside if you wanted to and put parentheses here, and it would be the same thing. Now, finally, we can also express, use identity to express what we call superlatives. A superlative is when we say that somebody is the absolute top dog, right? Something is the most or the best, etc. So think about a statement like Maria is the most curious student. Now, the trick is, first of all, to think of most in terms of more, right? So let's go ahead and define a relation C such that if we were to say, for example, that CAB, that means A is more curious than B. Okay, so how would we do that? Well, first of all, notice that this does tell us that Maria is a student, and we want to capture that. And the easiest way to capture that, the only way really, is say Maria is a student. But there's something else. So and, right? Maria is a student and what? Oops, sorry. Okay, so Maria is a student and what? Well, try that. See what you come up with. Now, you might think you could do this without identity. You might say, well, yeah, okay, and for all x, if x is a student, then Maria is more curious than x. What would be wrong with that? There is something wrong with it. Can you say what it is? Right. So what's wrong with it is that it implies that Maria is more curious than Maria. Right, so Maria is a student for all x. If Maria is a student, right, Maria is a student, it would follow that Maria is more curious than Maria. Maria is not more curious than Maria, of course. So what we need to do is figure out a way to avoid saying that. So we want to say something like this, but rule out the possibility that Maria is more curious than Maria. So one way of saying that is to say, think like this. Look, for every student, if Maria is not more curious than that student, then that student is Maria, right? For every student, if Maria isn't more curious than that student, then that would have to be Maria herself. So that says that Maria is more curious than every other student. So Maria is a student, and for all x, if x is a student and Maria is not more curious than x, then x is Maria. Make sense? Yeah, it does make sense, but there's a big difference, as you know, between it making sense and actually being able to write it yourself. And so that's what we'll work on with the study questions. Before we do, just want to make sure that you realize that working on identity can really challenge your grasp of the distinction between names and predicates, right? So this is something you really want to pay attention to while you're working these study questions. So again, just to remind you, notice that Stan only likes Martin and Stan only likes martinis. They have the same grammatical structure. They seem on the surface like they would be treated in the same way. But you know, if you just take a moment, stand back, Martin is what? Martin is the name of a person, and martinis is a predicate, right? There's being a martini, but martini isn't the name of a particular individual. At least this is being used here. Okay, so how would you write these? How do they look? In predicate logic? Well, the first one would be written as, well, Stan does like Martin. Stan likes Martin. And for all x, if Stan likes x, then x is Martin. Stan only likes Martin. But the second one doesn't involve identity at all. Just tells us that Stan only likes these things called martini. He doesn't like anything else. He doesn't like people. He doesn't like rocks. He doesn't like birds or mountains or anything else. He only likes martinis. So for all x, Stan likes x if and only if x is a martini. Okay? Stan only likes martinis. So just look at these. They're very, very different. And the difference is because we're talking about a name in the first case, an individual in the first case, and a predicate in the second case. All right. So let's go ahead and do some study questions. And there's quite a few of them here. Some of them are about focusing on how to do the translations, and the rest of them will be how to interpret statements in a model.